What's up, mathematicians? Welcome back to our lesson on applications of trigonometry. Now, of course, we are focusing on right triangle trigonometry in this lesson, but I thought I'd show you an example before we wrap up the lesson where you can use these tools of right triangle trigonometry, even though you may not see a right triangle. At least it may not be obvious to you when you look at the problem. And this approach could be used to find the distance across a river, a canyon, a channel, some sort of chasm, I guess, that was difficult to cross and take a tape measure across. So let's dive into the example. And here it is. So we're going to imagine for this scenario that there is a city, maybe on this side of the river, and maybe they have a ferry system, but they want to build a bridge, right? And so they pick sort of a narrow spot on the river and are trying to figure out, okay, what is the length? What's the distance across the river at this spot so that, as we're planning out this bridge building project, we'll know how long the bridge needs to be. So we're trying to find that distance right there for whatever purpose. But in our scenario, it's imagining that a town wants to build a bridge across the river. Okay, now you'll notice here that we do not have a right triangle. And the reason for that might be, because the river doesn't, if it were just a straight river, right? If it were perfectly parallel banks, then you could make a right triangle. But if it comes in at angles, you may not be able to make a right triangle. Okay, so, and since we want to use these 2 points as the endpoints for the bridge. So we see here we have a 23-degree angle. Here we have a 113-degree angle, and we want to know this length right here. Well, since there is land between this point and this point, you could walk across, take a tape measure or something, find a way to measure that. So we'll go ahead and say that they have measured this distance, and it's come out to about 142 meters. Okay, so we have this distance here of 142 meters, and we want to know this distance right here. Okay, so the key is in recognizing that we can make a right triangle out of this situation. So I'm going to use this triangle here. I'm going to use the right angle as a way to draw it in here. Later, we'll learn how to use like a compass and a straight edge to construct a perpendicular, but I'm going to go ahead and use this. So there we go. I have now drawn in a line perpendicular to this line over here. And so I have a right triangle. So I can use the tools of trigonometry to find this length right here. Now I'm going to need to give it a different variable because I'm using x for this. So let's go ahead and just call that distance a. And if I look at this triangle, let's write out what the information we have. So let's see. This is my hypotenuse, and so let's go ahead and divide it. Let's divide both of these by the hypotenuse at the outset. So we have 142 divided by 142 is of course 1. We're scaling this down to a unit right triangle. And then over here, let's go ahead and scale that down too. So we have a over 142. And from the perspective of this angle, you can always rotate your paper if it makes it easier, but from the perspective of this angle, this is the rise, meaning this is the value of the sine. And so what does that tell us? The sine of 23 is the rise. So let's go ahead and write that over here. Sine of 23 degrees is equal to a over 142. Okay, that looks kind of like a 9. That should be an A. And now in order to solve this, I'll just multiply both sides by 142 times 142. And I can plug this in my calculator. So 142 times the sine of 23 degrees, and I get 55.48. I'll round to the nearest tenth of a meter. And so I get A is equal to 55.5. Oh, sorry about that. Well, I'll just round to the nearest 100th, or 8, because I wrote the wrong digit there. So that's how we'll fix it. We'll round to the nearest hundredth, nearest centimeter in this case. So now I know this length right here. It's 55.48. But if you look at this triangle, this is the triangle we need to work with. And you might say, well, we don't have enough information about that triangle because we don't know what the measure of this angle is. So this is where we need to use that fact about the angle sums of triangles. And as I mentioned a couple times in a previous video, not only is the angle sum of all these triangles equal, but it seems that it's going to end up being 180 degrees. So if that's true, if the angle sum of this triangle is 180 degrees, then we can figure out this angle right here. So this is a 23-degree angle. This is a 90-degree angle. So let's take 180 minus 90. That gives me 90. And then I'm going to subtract 23. And let's see, 90 minus 23 is 67. So 67. That means for this 113-degree angle, this portion of it that's in this triangle is 67 degrees. And so let's see, I'll write that over here. So this is a 67-degree angle. Now I'm only talking about the portion in this triangle. Maybe I'll add it as another arc there. And let's use a different color to make it easier to distinguish my different arcs. Now I want to know this angle right here. Well, I know that the total of these two is 113 degrees. So I can take 113 and subtract 67. Okay, so let's see, 113 minus 67. Well, 100 minus 67 is 33, and 13 more than 33 would be 46. So this should be a 46-degree angle. So that's that angle right there. Okay, so this was starting to get a little messy, so I decided to draw another copy of this triangle right down here. Probably didn't quite do it to scale, but that's okay. So this is our right angle. This is the distance we want to find, the distance across the river, x. And then this distance right here was a up here, and we already solved for it. We know that that is equal to 55.48 meters. So now I can go on to use my trigonometry facts to solve for this distance right here. Okay, so rather than divide everything by the hypotenuse this time, I'll take the more traditional approach. I like to sort of go back and forth, and that way you get some practice using either approach. And you know, obviously use whichever one is most comfortable for you, makes the most sense to you. So let's write out what we know here. So opposite, adjacent, and hypotenuse. I encourage students to actually write these out so that it makes it easier to make sure you're picking the right trig ratio for the problem. Okay, so from the perspective of this angle here, this 46-degree angle, the opposite, this side right here, I don't know what it is, and I also don't care what it is. The hypotenuse, of course, is the longest side right here, so we can put an X. And the adjacent is this side right here. It's next to the angle, but it is not the hypotenuse, not the longest side. So that's going to be 55.48. And keep in mind, of course, you can always rotate your paper around if you want to see that, okay, this is my hypotenuse, this is my rise, this is my run. Now when I rotate it around, it makes it even clearer that I didn't do a good job of drawing a right angle there. But anyway, you can see it here. And so let's go ahead and figure out what the value of x is, this distance across the river. Okay, so I know the adjacent and the hypotenuse, don't know the opposite. That means I need to use the cosine, because the cosine involves the adjacent and the hypotenuse. Okay, so we know that cosine is equal to adjacent over hypotenuse, and therefore the cosine of my angle, cosine of 46 degrees, is equal to the adjacent 55.48 divided by the hypotenuse x. Now, in order to find the value of x, I will need to multiply both sides by x. And I'm running out of space here, so let me move this down a little bit. So I have x times the cosine of 46 degrees is equal to 55.48. Now, in order to solve for x, I divide both sides by the cosine of 46 degrees. That is a 4, even though it looks kind of like a 9 here. So divide both sides by the cosine of 46 degrees. Cosine 46 degrees. And so I get that x is equal to, let's plug it in the calculator and find out. All right, 55.48 divided by cosine of 46 degrees. And I get 79.87 if I'm rounding to the nearest centimeter, the nearest hundredth. So 79.87 meters. Okay, so now we know the distance across the river at that point. So this town that wants to build their bridge, they know that the distance that it has to span is 79.87. Of course, they'll need to go a bit extra on either side. But in terms of finding that particular distance from this point on the shore to that point on the shore, we now know it, 79.87 meters. Okay, so this pretty much wraps up our brief investigation into the trig ratios, sine, cosine, and tangent. I will do one more video for this lesson showing some more advanced trig applications. And in the next lesson, we'll look at another tool for measuring right triangles, one that most of you are probably already familiar with. Now, this initial survey of trig ratios only scratches the surface, okay? It's important to understand that there's a lot more here, okay? We could fill an entire course if we wanted to by looking at the trig ratios, if we want to dive really deep, especially going to the unit circle and looking at them as functions. But we want to keep this unit on measurement relatively short, and we want to move on to area. We want to talk about measuring area and then get on to other things on our roadmap. So yeah, as I mentioned, I will do one more video on a little bit more advanced applications. I would say it's optional. You can skip it if you like, but if you are interested, check out that video. And yeah, as always, thank you so much for watching. If you did learn something or found this video to be interesting, please do like and subscribe, and I'll see you in the next video. Bye-bye.